everyone. We're going to differentiate the function h of z. So we'll get started. The first thing I'm going to do is just rewrite this. So this is h of z equals ln, and I'm going to write a squared minus z squared divided by a squared plus z squared to the 1/2 power. Now I'm going to use my properties of logs and use law number 3 and expand this. So I'm going to have 1/2 ln of a squared minus c squared divided by a squared plus c squared. Then I'm going to use law number 2 and expand that further. So it's going to, when you expand it, I'm also going to distribute the 1/2 when I do it. So this is going to give us 1/2 ln of a squared minus z squared minus, and I'm going to go ahead and distribute that 1/2. And that's going to be ln of a squared plus z squared. All right. Now when you do the derivative, I'm going to go ahead and try to squeeze that in here. So we're going to do h prime of z. So for the first part, just copy down your 1/2. And for ln, we're using this right here. So it's going to be 1 times a squared minus z squared times the derivative of negative. We're doing z, not a. So that's going to be times negative 2z. That's the derivative of the inner function. Okay, then do this one. Same thing. 1/2 times 1 divided by a squared plus z squared times the derivative of z squared, which is 2z. Now in the next slide, I'm going to be canceling this out. We're going to have a z in the numerator, a negative z, and here we're going to have a z. So when I write that out, I'm going to have equals z divided by c squared minus a squared, and then minus z times z squared plus a squared. And what I did is I just reversed this. Before we had a squared minus c squared, and we had a negative. So if you ever have something like that, negative 1 times a squared minus c squared, you can reverse it by multiplying both the numerator by negative 1 and the denominator by negative 1. And that's why it gives you that. We actually had a z here, actually. All right. So that's just a little trick there. Now, let's get our common denominator. And that's going to be z squared minus a squared times z squared plus a squared. And then we're going to cross up. So this is going to be z times that. So z squared plus a squared minus z times z squared minus a squared. All right. And this equals z cubed plus za squared minus z cubed plus za squared all over your least common denominator. I'll just write it like that. And now we're going to write out the final answer, and let's see what happens here. We're going to get these two cancel. So basically we just have 2 of these. We have 1 here and 1 here. So this is all going to equal 2az squared divided by z squared minus a squared times z squared plus a squared. And this part here can be reduced as z to the 4th minus a to the 4th. That's kind of why we changed it in here. It has this form of a squared minus b squared equals a minus b times a plus b. But in our case, we had squares here, so now you're just going to use the fourth. So I'll write that answer again so you can see it. So the final answer is going to be h prime of c equals 2a squared c times z to the fourth minus a to the fourth. And again, this is just because this can be expanded to z to the fourth. C squared minus a squared times c squared plus a squared. Just with your factoring facts. And that's it. Thank you. Have a nice day. Bye-bye.